this video, we're going to start with a special right triangle refresher, okay? So, you should remember from geometry about two particularly special right triangles. We have our 45, 45, 90 and our 30, 60, 90. Okay, those are our two special right triangles. Okay, and the reason they're special is because there's actually a nice little relationship between the legs and the hypotenuse for these. Okay, there is a ratio of sorts. Okay, and I'm going to focus on the 45, 45, 90 first. Okay, well, since these two angles are congruent, that means that their opposite sides are congruent. So I'm going to call each of these sides x. So these sides are going to be equal. That's simple enough. It should be simple enough. If the angles are congruent, that means their sides must be congruent. Okay, and there's actually a nice relationship with the hypotenuse here. The hypotenuse is always going to be for 45, 45, 90 x times root 2. So whatever the side, whatever one of these legs, or both of these legs in this particular case, so if we have the measure of one of the legs, we simply multiply by the square root of 2 to obtain what the hypotenuse length would be. Okay, and let's take a look at an example. So I'm going to go ahead, scroll down just a little bit, and let's say I had a right triangle. Okay, and let's say this is a 45, 45, 90, just like the one up there. And let's say I had this side was 6. Okay, and I want to find the rest of the sides. All right. Well, if this side is 6 and these angles are congruent, that means the sides have to be congruent. So that means that this also has to be 6. Okay? So our sides are both 6, our legs are both 6, since it's a 45, 45, 90. And in order to find the hypotenuse, I would just do the leg 6 times the square root of 2. And that's it. That's all it is. All right? So if you have one of the legs of a 45, 45, 90, it's actually fairly straightforward. Okay, let's say we had something that was just a little bit more complicated though. Let's say we had something like, let's say we had a 45, 45, 90. All right, so I'm going to make this 45, 45, 90. And let's say we had the hypotenuse though. Let's say we had that the hypotenuse was 10. This makes it slightly more challenging, okay? Now, they're telling us that the hypotenuse here is 10. Well, remember that the hypotenuse should be one of the legs times the square root of 2. So what that means is in this problem, we somehow got 10 by doing the length of the leg, I'm going to call x, times the square root of 2. And now I can just go ahead and solve for that leg. Okay, I can solve for x. So I'm going to divide each side by the square root of 2. But remember, we can never have a radical in our denominator. So to rationalize this, I'm going to multiply by root 2 over root 2, which is going to get us 10 root 2 over 2 is equal to x, which reduces 10 over 2 is 5. So that means that each of these are 5 root 2. Okay. Now there's another thing I do want to talk about real quick before I move on to 30, 60, 90, and that's sine and cosine of 45 degrees. Now, if we look at like this one right here, we should remember that sine is opposite over hypotenuse. Okay? So for example, let's say I want to do sine of 45 degrees. And I can use either one of these. It doesn't necessarily matter. I'm going to go ahead and use this one. So if I want to do sine of 45 degrees, that's opposite 6 over hypotenuse 6 root 2. And remember, I can't have a radical in my denominator. And I can also simplify this. 6 over 6 is 1. So that becomes 1 over root 2. But I can't have a radical in our denominator, so I'm going to multiply by root 2 over root 2, which ends up getting us that sine of 45 degrees. If I multiply this out, it would become the square root of 2 over the square root of 2. And what's nice about this is that if I did cosine of 45 degrees, if I did cosine of 45 degrees, I would end up with the exact same problem. I would end up with 6 over 6 root 2, which once again reduces to the square root of 2 over the square root of 2. So notice that sine and cosine of 45 degrees are the same. And I would end up with the exact same problem if I did sine and cosine of 45 degrees for this right triangle here. So if I did sine of 45 degrees, I would get 5 root 2 over 10, which reduces to 1 root 2 over 2. Notice that we got the exact same measure. And for cosine of 45 degrees, I would once again have 5 root 2 over 10, which would once again get me the square root of 2 over 2. And if we did it for our original one, with just the x and the x root 2, we would end up with the exact same thing, okay? That's very, very important, especially once we get to something that is called the unit circle. You need to remember that sine of 45 degrees and cosine of 45 degrees is always root 2 over 2 every single time. Okay, because trig ratios are consistent amongst a angle. Okay, so sine and cosine of 45 degrees will always be the square root of 2 over 2. Make sure that you kind of burn that in your memory. Make sure you're able to find missing sides as well. You are going to need to be able to do this, but definitely make sure you remember that sine and cosine is always the square root of 2 over 2. Okay, and in the next video, we'll go ahead and take a look at our 30, 60, 90.